Hello, class. This is lesson 2 of your primer worksheet on Physics Unit 2. It's going to be the investigation of waves. And in this one, we're going to be looking at sound waves and electromagnetic waves. Magnetic. All right. And the objective for this one is to develop an understanding of two types of waves. And like I said, sound and electromagnetic. Okay? And section 1 is going to deal with sound waves. And that can be found on chapter 21.1 and 21.2 and on pages 600 through 611. So you can refer to your textbook if you want to. And the first thing we're going to talk about is a sound wave. And a sound wave is a longitudinal wave that is caused by vibrations and that travels through a material medium. A longitudinal, and in the last lesson you'll learn what a longitudinal wave is. That is caused by vibrations and that travels through a material medium. Okay? And the type of wave is a mechanical wave. And if you remember from the last lesson, a mechanical wave is a wave that requires a medium to transfer energy. Okay? So the key word here is medium. All right? A sound wave needs a medium to transfer energy because it's vibrations. All right? Now, when we talk about a sound wave, we can talk about the speed of sound. And this varies depending on the medium and medium's temperature. And the medium's temperature. All right? And the thing you got to remember here is lower equals slower. And the lower is referring to the temperature, and the slower is referring to the wave. Okay? So the lower the temperature, the slower the wave. All right? Now, an example of the speed of sound would be in air. It would be 343 meters per second. So if you were to exceed 343 meters per second in air, you would break the sound barrier and you'd hear a large boom. Okay? And in water, it's 1,482 meters per second. So as you can see, the medium changes between air and water, so then the speed of sound would change. So you can take that into effect. Air and water. All right? Now, pitch is another thing that we can look at with sound waves. And pitch is a measure of how high or low a sound is perceived. How high or low a sound is perceived to be. And this depends on the frequency of the wave. And in last lesson, you talked about frequency, and that's how many waves go by in a given time. So an example of this would be low frequency equals low pitch. All right? In high frequency would equal high pitch. So if you hear a really high sound, you know that it has a high frequency. And if you hear a really low sound, you know it has a low frequency. So they're directly related. All right? Now, sound waves, you can also notice a Doppler effect. And this is in observed change in the frequency of a wave when the source of the observer is moving. And the thing you got to look at here is the source of the mover would be a wave. Okay? All right? An example of this would be an ambulance. All right? And you could be standing on the curve, and as the ambulance goes by, you'd hear that Doppler effect. It'd get louder, and then once it passes, it starts to get farther and farther away. So this would be a change in the frequency, because as it gets closer to you, the frequency would be much more. It'd be a high frequency, so the pitch would, so it'd be, the loudness would be higher, and you'd hear it a lot more. And then as you go farther, the wavelength would get farther away. Okay? So that would be a Doppler effect. Or in another example would be the blasting of a horn as the driver is going by. Okay? Now loudness is another thing we look at with sound waves. Loudness is the extent to which a sound can be heard. Okay? And increased loudness is caused by an increase in the amplitude. Okay? So if you increase the amplitude of the wave, the loudness increases. All right? And if you decrease the amplitude of the wave, it decreases in loudness. That's also a direct relationship. All right? And the way we measure loudness is in decibels. And this is the most common unit used to measure loudness. And that's decibels. And the symbol is dB. Okay? And if you were to, kind of an example for loudness would be 20 decibels would be whispering. and 60 would be a normal conversation. All right, and a threshold for pain, so when you'd hear pain in your ear, would be 120 decibels. So if you get up to 120 decibels, you'd start feeling pain in your ear. So a really, really loud rock concert or something like that. All right, and now we're going to move from sound waves to section 2, which is on electromagnetic waves. And electromagnetic waves can be found in chapters 22.1 and 22.2, which are pages 632 through 643. All right? And the first thing we're going to look at is electromagnetic waves. Okay? And an electromagnetic wave is a wave that consists of electric and magnetic fields that vibrate at right angles to each other. So if they're at right angles to each other, they're perpendicular to each other. All right? And that is the electric and magnetic fields that are perpendicular to each other. All right? And now what this box is here for, as you can see, I want you to go to page 632 in your textbook and look at figure 1. And I want you to either put a description in your own words of the wave or even try to draw the wave. Okay? And I'm going to kind of show you right here what you're looking at. So if you go on to the online textbook or open up your book, this is an electromagnetic wave. There's a lot going on here. All right? As you can see, it's got the magnetic fields and the electric field. So magnetic field is in the blue right here. And the electric field is in the red. And this yellow line shows the direction that the wave is traveling. All right? So if you can either pause it now and talk about it, or you can listen to the rest of this lesson and then go back and fill in that spot with either a description of the wave in your own words or draw the electromagnetic wave. It'd be cool to draw it. I'm not going to try drawing it because I'm not a very good artist, and it would be very difficult for me to draw it. And you would not see anything remotely close to a wave if I were to draw it. All right, so that would be an electromagnetic wave. Now we're going to go on to radiation, which deals with electromagnetic waves. So radiation is the transfer of energy as electromagnetic, I'm just going to put EM, waves by vibration of an electrically charged particle that causes its electric and magnetic fields to vibrate, creating an EM wave. All right? So radiation, again, is the transfer of energy as electromagnetic waves by vibration of an electrically charged particle that causes its electric and magnetic fields to vibrate, creating an electromagnetic wave. So that is a very heavily worded definition. All right? And basically what it's saying is for the vibration of the electric and magnetic fields creates electromagnetic wave, which is radiation. Okay? And this deals with light, right? And when you're looking at the speed of light is 300,000 kilometers per second in a vacuum. So like space. In a vacuum. I spelled vacuum wrong. It's only one C. All right? And as a reference, takes 8.3 minutes for sunlight to reach Earth. Okay? Which is a long time considering the fact that it's traveling at 300,000 kilometers per second. So that would be the distance of the sun to the Earth. So 8.3 minutes for a beam of light to reach the Earth from the sun, which shows how far it is away. All right? Now, with electromagnetic waves, we categorize them based on frequency, energy, and wavelength into an electromagnetic spectrum. All right? An electromagnetic spectrum is all of the frequencies or wavelengths of electromagnetic radiation. All right? So it categorizes them based on their frequencies and wavelengths. All right? And I'm going to list them all now, and I'm going to list them based off starting with the longest wavelengths and lowest frequencies and going to the highest or the shortest wavelengths and the highest frequencies. All right? So the first one would be radio waves. Microwaves is the second. Infrared. And then visible light, so the light we can see. Ultraviolet light. X-rays. And gamma rays. So that would be shortwave radiation. And again, radio waves have the longest wavelength and the lowest frequency, and gamma rays have the shortest wavelength and the highest frequency. All right, and that's gonna clear up lesson 2 of your Physics Unit 2 waves primer worksheet on sound waves and the electromagnetic spectrum. Thank you.